Hello and welcome to the Gus Codes. I am Gus, and in this session of xganso I'll give an overview of the unit data infrastructure, including the data service, data managers, data representation and their configuration. This service handles all access to static game data and marks a new phase of xganso development, moving from isolated systems to integrated ones, enabling sustainable and scalable progress. Let's start coding. When I started thinking about the characters, I quickly ran into a problem. I needed a way to instantiate them and then adjust their stats and parameters for testing and balance. But doing all of that directly in code, even in Python, gets messy really fast. In the early prototype, I handled everything directly in code as a proof of concept, but every change meant digging through files, updating variables, and making sure nothing broke along the way. It wasn't scalable and it definitely wasn't organized. So the core problem became, how can I manage data in a clean, structured and scalable way that makes iteration and balancing easier? The solution was to move all static and configuration data outside the codebase and store it in a dedicated repository. That way I can adjust values, add new units or tweak balance without touching the game logic at all. But just storing data externally isn't enough. The game still needs a clean and consistent way to access it, so I needed a unified service that could load the data and act as a single source of truth for the entire game. This approach keeps the game logic separate from the data, makes iteration much easier, and sets the foundation for a scalable system as more types of data are added. Next, I'll walk through the xganso architecture and show how this concept is implemented. In xganso, the core of the game is driven by a central engine built on an ECS framework. But the engine itself doesn't hold everything. It still needs to interact with external systems to fetch data, like the unit data, so it can instantiate the right units with the correct stats. To support this, xganso uses services that act as the bridge between the engine and anything outside of it. Whenever the engine needs information, such as unit definition, stats or configuration, a service provides that data no matter where it's stored. In our case, that information comes from data files. The service layer loads it, organizes it, and delivers it in a clean and unified way. That's the high-level architecture. Now we can dive into the data service itself. The data service is the entry point for anything in the game that needs static data. The engine never touches files directly, it only communicates with the data service. The service provides a unified and consistent way to request information, whether that's unit stats, abilities, or anything else we add in the future. Internally, the data service doesn't actually load data itself. Instead, it delegates that responsibility to data managers, each one responsible for a specific type of data. For this to work, the managers must be registered with the service, so the service knows which manager handles which data type. All data managers share the same underlying logic, making the code highly reusable and easy to maintain. Each data manager is responsible for loading and organizing one specific type of data. For example, the unit data manager handles everything related to unit definitions, while feature managers might handle abilities, items or missions. This is achieved by parameterizing each manager according to where its data lives, how to load it, and how to structure so the rest of the game can use it easily. This modular design makes the system highly scalable. Adding a new type of data doesn't require changes to the data service or the data manager. You just create a new data type and its data descriptor, register them as a new data manager, and the architecture takes care of the rest. For the data format, I chose YAML. It's lightweight, human-readable and easy to edit, which makes it perfect for defining game data during development, as the project grows and new data types are introduced. Each unit in xganso is defined in its own YAML file. These files describe everything the game needs to instantiate the unit: ID, name, class, sprites, stats, abilities, any other information that we might add in the future. Because the files live outside the codebase and are human-readable, it's simple to adjust values for testing and balance, or to add new units without touching the game logic. This approach also opens the door for future tools, automated validation, or even modding. The data managers load these YAML files, structure the information into data descriptors, values, Pydantic models that validate the input before handing it off to the data service, completing the data flow from file to gameplay. Data managers must be registered with the data service. Once registered, the service knows exactly which manager to delegate a request to, ensuring that every part of the engine gets a single, consistent source for that information. To connect everything, I created a data service configuration that defines which data managers the game should use and how to instantiate them. This means I don't need to change the game code whenever I add a new data type. I just add a new entry in the configuration and the data service registers the new manager automatically. This keeps the system flexible and makes the data layer fully modular. As the project grows, I can introduce new data types or change existing ones by just updating the config without touching the engine or the services. To summarize, today we looked at the problem of handling game data and explored the xganso solution, a fully modular and highly scalable data service supported by data managers and YAML files. In the next session, we'll continue expanding our basic service with the asset service, factory service, and service registry, completing the pipeline from data to unit instantiation. Thank you for your time, and see you in the next session.